So I'm delighted to be here in Telangana. I have, interacted with Hyderabad for many years now, and it's really exciting to see the forward-looking vision of the Telangana government in establishing AI leadership in India. It's very inspiring to me sitting in the United States. So I'm delighted to be a small part of that effort. I thought I'd start by just taking us a little bit under the hood of the technologies that Mr. Salman Khan just talked about, because when we think about how to be responsible with AI, how to gain business value out of AI, what are the societal challenges that are going to emerge from artificial intelligence, it's useful to try and understand exactly what's going on under the hood of these technologies. We've all been exposed to generative AI. We've used ChatGPT. Perhaps we have composed music using a generative AI system. I'm sure many of us have generated art. And so we know that this is a new class of artificial intelligence, and it is generating new content by learning it from patterns and examples in existing data. And so it's a fascinating leap forward that we've seen go mainstream over the last 2 years. And it raises this question, right, of artificial intelligence has been around for a long time. How did we go from AI that can make decisions, decide what to recommend to you, what ad to serve to you, should this person get a loan, is this fraudulent, is this credit card transaction fraudulent, to systems that are actually sort of composing poetry in the style of Shakespeare, creating paintings, creating videos. And to understand the present, I think it's useful to spend a minute looking at the past, because AI has been around for 70 years. And 30 years ago, AI was all about taking human expertise, interviewing a bunch of people, codifying their knowledge, and putting them into what are called expert systems. And then we had the machine learning revolution in the 1990s, where we took the step forward of getting computer systems to learn from examples by themselves. So human beings would say, here are the features that matter, and the machine learning system would come up with its own rules by learning from examples. Now, this was followed a few years later by the deep learning revolution, which was another step forward, where you gave a large neural network raw data, and it would not only come up with the rules by itself, but it would come up with the features by itself. This started with image recognition, and now this is the most widely used technology under the hood. And a massive, large neural network, a deep learning system, is what is sitting underneath these powerful generative AI systems like GPT. But we have now entered this platform era, where you have these general capabilities of artificial intelligence that are embedded into these large machines that we can draw on in the same way that applications draw on the capabilities of operating systems. So 2 questions that come up are, why did it take so long? Well, and this is an important point to think about, it's because these deep learning systems are incredibly reliant on computing power. And so computing had to become cheap enough for massive deep learning systems to become affordable. This wasn't possible 10 years ago, even if the technology had existed. And I bring this up because leadership in AI isn't just going to be about talent, it isn't just going to be about skills, it isn't just going to be about scientific breakthroughs. A very important part of the competitive landscape, both within companies and globally, isn't just these other dimensions, it's a scale game as well. There are going to be tens of billions, hundreds of billions of dollars of computing power infrastructure that are going to drive who is going to be the eventual leader. And the second question that comes up is, how did we make this leap from prediction to generation? Well, over the last few years, we've done 3 things. We've said, well, if we want to understand language, we break it down into these little pieces called tokens. These aren't just English language words or Telugu language words, they're also proper nouns like Hyderabad or Charminar, Paris, France. And we create what are called embeddings. This is 1 more minute of lesson, and then I'll get into sort of the more, I'm a professor, I like to teach when I'm on stage. And then we create these things called embeddings. These are sort of mathematical representations of these words or phrases or tokens, but they are not created based on specifying to the machine that these two words are synonyms. They are learned by how these words are used in practice. So an embedding then discovers that Hyderabad is close to Charminar, or that the relationship between Paris and France is the same as the relationship between Berlin and Germany. And then finally, in 2017, we had the attention mechanism breakthrough, where words that, for example, have multiple meanings, that you can learn how to generate words by understanding what they mean from the context that they are used in. So if I have a sentence that says, I'm going to paint my car orange, you know that orange is being used as a color rather than a fruit. If you say that this apple tastes good, you know that you're talking about apple as a fruit rather than Apple, your iPhone, at least one would hope. And so you put these three things together, tokens, embeddings, and transformers, the attention mechanism, and then you get to the point where sitting inside this massive machine is a system that has learned from massive amounts of text, the patterns that are contained in grammatical structure, common sense, and it works fundamentally by predicting the next word. That's how we make the leap. We are building a system that can now, given a bunch of content, can predict the next word. You take that word, you attach it to the next thing, it predicts the next word, and so on, and so on, and so on. And so that's how we've made the leap from predictive AI to generative AI. And how these machines are trained is really important in what follows. So you might say, okay, now we've got things like GPT, Claude from Anthropic, we've got Llama, there's a whole bunch of homegrown large language models. How do we take them and make them into something useful? How do you create an investment advisor? How do you create a medical diagnostic system, a legal advisor? How does a company create an HR system that answers questions about vacation policy? How does a company create a customer service system that knows enough about your products to be able to answer these questions? Well, there are three broad approaches. Very few people are building their own systems from scratch anymore. Perhaps Bloomberg was the only company to do this a couple of years ago. Most people use one of two methods: fine-tuning, where you're giving the system new data and changing the underlying foundation model, and systems like RAG, where you're not changing the underlying large language model, but you're doing all of the context discovery on the outside. You're saying, well, I'm going to build a separate search system that figures out what document I should provide as context, and then I send this to a generic large language model. So that's the state of the art today. Now let's take a glimpse into the future. Where is generative AI going? Some of you have already used image generating systems. Some of you perhaps have seen the early examples of video generating systems. But that's certainly on the horizon. Over the next 5 years, we'll have increasingly sophisticated AI systems that can generate video on demand based on specifications. That's a very exciting development. Another development that doesn't receive as much attention in the popular press is that generative AI is revolutionizing drug discovery. I told you that we have tokens and embeddings of language from which you can use that to find out, you can learn grammar, to learn word usage, to learn common sense. In a similar way, a generative AI system for drug discovery is not generating text or images, it is generating molecules or proteins, and it is generating them having learned from millions of examples the patterns of chemical dependencies, the patterns of biological relationships that exist. And so this is perhaps one of the most exciting frontiers for generative AI. And then if you think about human intelligence or species, living things intelligence, there's certainly among human intelligence, language is a very big distinguisher. But our ability to navigate physical space on our own, to learn how to move, is another distinguishing intelligence characteristic. And to me, that's another really exciting frontier of generative AI. Of course, we have seen autonomous vehicles already. They gather data using LiDAR, which is what you're seeing, one sort of sensing technology, using video cameras to sort of map their surroundings. They even use radar, that old technology that has been used for a long time. They combine this with satellite data on precise locations and very detailed maps. But they are fundamentally today still rule-based systems. There are millions of rules that are sitting under the hood. But if you think about how you and I might drive a car or drive a motorcycle, we're not reacting instantaneously to our environment. We are making sort of intelligent predictions about what is going to happen in the next few seconds. You're approaching an intersection, someone is approaching the same intersection. You are making tacitly a prediction that perhaps the person is going to be crossing the road when I reach the traffic light, so I need to slow my car down. So this is the next frontier of generative AI, which is creating systems that are called world models, and there are already prototypes of these, which, given data about what the world looks like today, what your physical environment looks like today, encoded as video data or LiDAR data, what will the physical world look like in a couple of seconds? And the generative system is generating this prediction of what the world is going to look like in a couple of seconds. So this is definitely a space to monitor, but this brings me back to the computing power point, which is that the language models themselves have required these massive infrastructure developments. World models are 2-3 orders of magnitude more computationally intensive. And so countries around the world are realizing that a big part of staying on the frontier of AI isn't just getting enough NVIDIA chips and building these massive infrastructures, but that electricity or power is going to end up becoming a constraint as well. Just to give you a sense for how power intensive AI is, a typical large tech platform to run its AI systems uses the power output of the equivalent of a nuclear power plant. So even a single company requires as much power as is generated by a typical nuclear power plant. And that is today, when generative AI is in its infancy. It hasn't yet been deeply integrated into our lives. And so part of the reason why there's been so much recent interest in nuclear fusion technology into sort of next generation power systems is because there's an anticipation that at some point in the next 10, 15 years, electricity is going to be an access to cheap and affordable and sustainable electricity to power these massive AI infrastructures is going to be on the boundary of what constrains or enables a country or a government to sort of move forward. Now let's spend 5 minutes talking about how companies are getting business value from these generative AI systems. Over the last 2 years, there have been dozens of studies that have established, not surprisingly, that generative AI increases individual productivity. It makes people who write faster. It makes people who translate faster. It makes people who edit documents edit faster. It allows people who write computer programs to program faster. It allows consulting teams to come up with better solutions faster. And so these rises in individual productivity have been established. But to me, that's not the exciting thing. Okay, the exciting thing is going to be what's in the future. And to understand what's in the future, again, let's look at the past. 20 years ago, Amazon, a large retailer, was faced with a new challenge. And I'm using Amazon as an example because I've got a good video of them. I mean, I could be using Flipkart, which has incredible automation technology in its Malur sort of fulfillment center. But Amazon was faced with a new problem, which is when someone places an order, you have to put a bunch of different items in a box and ship it to them, right? And someone might have ordered a hairdryer, they might have ordered some clothes, they might have ordered some toothpaste. All of these are in different parts of the fulfillment center. How do we efficiently get someone to go around this fulfillment center, collect all these things from these massive shelves and put them in a box in a cost-effective way? And so the productivity increasing approach would be to say, let's build a robotic system that rapidly moves around the warehouse, maybe a drone that sort of flies around, picks things off and puts them in a box. But the approach that ended up being used and the approach that is going to bring the revolutionary gains in AI, like 2 companies, was taking the people to the shelves imagine a system where the shelves come to the people. So 20 years ago, if someone had made this suggestion, people might have said, well, what kind of psychedelic drugs are you on? Like, shelves moving to people, that's a great vision, but, sort of like go home, take a nap. But you look at the Amazon warehouses today, and this is what has been implemented. There are robotic systems where the shelves move around the warehouse in sort of this orchestrated dance, orchestrated by AI, and they move to the human who is then picking items out of the shelf and putting it in a box. So a critical lesson to be learned here is that value from these revolutionary new technologies may initially come from simple productivity gains, but the true business value comes from rethinking, how can my process be different? How can I do work differently based on the new capabilities? And part of the reason why I am confident that this is going to be the case is that history is on my side. Over 100 years ago, before the advent of electricity, factories were built around the power source because they would be powered by a steam engine or a water wheel, and so you'd build the factory next to the river, and the transmission of power was through these belt and line shaft systems. And so you had to sort of construct these rickety structures that people were surrounding the power source because you couldn't transmit. There was one power source, and the entire design of industrial production systems was constrained by putting people around the power source. Now, once the electric motor came along, maybe early productivity gains came from taking out the steam engine and plonking in the power source, but the revolution came from understanding that I could reimagine how work is done unconstrained by the fact that I need to put people next to the power source. That's where the assembly line, division of labor, scientific management came in, because everybody had their own little machine, and you could start to build production systems based on productive efficiency, not based on proximity to power source. And a final point on business value, humans have to trust the AI systems. Trust is a powerful driver of business change, and without sufficient trust in these AI systems, you're not going to see the business gains. Some of my research has established that when you have a familiar human-human interaction environment that someone can map the human-AI environment to, trust builds more rapidly. And I'll give you an example. In the United States, people are more likely to trust an AI system that is doing medical diagnosis than an AI system that is providing investment advice. And this seems mysterious, right? Because medical diagnosis is so much more high stakes than investing your money. The reason is that in the US, the typical interaction you have with your doctor is it's a stranger in a white coat who says, I'm an expert, here's what's wrong with you, and you agree. So talking to an AI system that says, I'm an AI in a white coat, here's what's wrong with you, you've been Googling your symptoms anyway. It's a familiar step from the human-human to the human-AI. Investment advisory, on the other hand, most people don't have this. The people who have it have long-standing relationships with their advisors. So talking to an AI stranger is something where building trust is a lot harder. And so understanding what builds human-AI trust is also central to getting business value. Now, that's the positive side. I think one of the challenges we are going to face in the near future is that AI is going to redefine what it means to be human. We are not sort of strangers to AI systems mapping who we are. All of you have a digital twin at every major tech platform that has understood your preferences and that is doing things like recommending products to you, deciding what's in your news feed, deciding what ads to serve you up. And so our preferences have already been digitized and mapped into AI systems at tech companies. This is not new. What generative AI allows us to do now is to create more sophisticated human twins. And so you can train a system now to write like you. And that's how these generative AI systems work, right? You give them some examples of what you want done, and they can learn how to do that in that person's style. So you're probably going to welcome the creation of your digital twin initially. right? I mean, like, it can write your emails for you, it can answer emails for you. Maybe, when you go on vacation, there's a chatbot version of you that your colleagues can talk to. The trouble is that, like, if you leave your job and go to another job, who's to say that your digital twin isn't going to stay behind, right? Or better yet, like worse yet, compete with you for your next job. So this idea that AI can replicate the creative style of individuals isn't just restricted to writers and musicians and artists. A very skilled foundry worker, their movements can be recorded to create a robotic system that encapsulates 30 years of experience there. You can put cameras on the wrists of a surgeon to gather really rich training data for a robotic surgical system, but that is also extracting at the same time the capabilities of this highly skilled surgeon and encapsulating them into a machine. A good business development executive who knows the cadence of, like, when to email, when to call, when to take the person out to dinner, like, when to send flowers, when to pull back. Those patterns can be codified into an AI system that replicates that expert and given to novices who then may not be 100% as good as the expert, but can sort of get up to speed really fast. So we are entering a world in which the body of work that you create isn't just your body of work anymore. It is a blueprint for your productive process, for your creative process. You might say, well, the law must have thought about this already. It has, but it's come on the side of saying that what you produce, you own, but you don't own the process of production. You own your works, but you don't own your style. You own your expressions, but you don't own your ideas. And this was the trade-off that copyright law created, because the idea was that if you wrote the first detective novel, that doesn't mean you should own all of detective novels. You want other people to also write detective novels. If you wrote the first hip-hop song, that doesn't mean you own all of hip-hop, right? And so that trade-off made sense in the pre-generative AI era. However, now, if based on the works that you have created, someone can extract the blueprint of your productive process, it raises the societal question of what are the boundaries around human capital and what facets of our human capital should we own. So to me, this is one of the most important policy questions that is raised by generative AI. I'll conclude by moving from human autonomy to strategic autonomy of countries. I know that there is a great amount of interest in AI sovereignty around the world today. I recently participated in a discussion among the ASEAN countries about the boundaries around what they want to put, sort of their partnership about, like, digital interoperability. Should that be extended into AI sovereignty? I think some of the plans that Telangana government has about the AI city, about the creating of the infrastructure, skilling, hugely exciting. The two guidelines I give governments I talk to when thinking about, like, sort of how do I approach the question of how sovereign should my AI be, what is the level of strategic autonomy should I attain, is to think about the right layers for independence. Do you want to be independent at the chip layer? I'm just checking the time, making sure that I haven't run over. Okay. Do you want to be independent at the semiconductor layer? This is not something that very many people can aspire to. Do you want to be independent at the cloud layer? Do you want to be independent or autonomous at the foundation model layer? Do you want to be autonomous or independent at the application layer? I use the LLMs of other countries, but, like, I'm building, like, my own homegrown applications. Do I want to be autonomous at the talent or skills layer? Each of these are a different level of autonomy, and I think thinking about what is the circle I want to draw around my strategic autonomy and where do I want to be sort of economically interdependent is a very important strategic question. And the other thing that I tell them is balance autonomy with regional partnerships. There are some things where you want to go it alone, whether it's a state, whether it's a country. There are other things where you want to lead the partnerships. You want to sort of create the standard that a whole bunch of other people follow. So these are the two important questions on strategic autonomy. I think we should all think about human autonomy and the boundaries around human capital ownership. I'm almost out of time. If you don't get to ask me a question now, I'm easy to find online. It was a delight to see all of you, and I look forward to your questions.
To stay